Hi Pre-Calc students, this is Chapter 7, Sections 3 and 4, and in this lesson we're going to be learning about double angle and half angle identities in order to evaluate trig functions. So before we get going, just something that I'm going to use a few times as we go through this lesson are our special right triangles, our 30, 60, 90s, and our 45, 45, 90s. And just there's lots of different ways that you could do this, but I just want to kind of inform you on the way that I'm going to be doing that. So if I come across a 30-degree reference angle, I am going to be using 1 on the short side, 2 for the hypotenuse, and the square root of 3 for the long side. So that is for a 30, 60, 90. And then for a 45, 45, 90, so if I end up in this lesson with a, that wasn't a very good picture, 45-degree angle, I will be using 1, 1, and square root of 2 for the hypotenuse. So if you want to write that down, great. If not, if you're just clear with that's what I'm going with for each of those, totally fine. All right, so double angle formulas, there are 3 of them for each of our sine, cosine, and tangent. So sine of 2 theta, so sine of 2 times a given angle is equal to 2 sine of that angle, 2 sine theta, times cosine theta. And you will definitely want all of these written down. You'll want to reference them often as we go through things. So sine 2 theta equals 2 sine theta cosine theta. Cosine of 2 theta is equal to cosine squared theta minus sine squared theta, and that's the one that I am going to use in these examples. However, there are different ways to write that because of our different trig identities. You could write it as 2 cosine squared theta minus 1, or you could write it as 1 minus 2 sine squared theta. So I would write all of these down in my notes, but I will, like I said, I will be using the first version in each of these examples. It'll work for each of our examples, so that's what I'm going to go with. And then the third one is for tangent. So tangent of 2 times an angle, or tangent 2 theta, is equal to 2 tangent theta divided by 1 minus tangent squared theta. Okay? And at that point, there really is nothing else to do except for to dive into some examples using the double angle formula. These are our double angles. So what we have here is telling us if sine theta equals 3 over 4, and theta is between 0 and pi over 2, find, and we're going to find 3 different things. We're going to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So you're going to see this worked out with all 3 of our double angle formulas. Okay, so before we really go anywhere, we need a picture of our angle. Okay, so there's our just basic set of axes, and then this piece of information is important. They're telling us that theta is between 0 and pi over 2. So we're working in radians here. Here's 0 radians. And then our pi over 2 radians would be there. And then, you'd have pi and 3 pi over 3 and so on. But that's all we need. So basically what this is telling us is that our angle is, or our terminal side, I guess we could say, is happening in the first quadrant, in quadrant 1. Okay? So now I'm just going to draw a picture. I don't know exactly what it's going to look like, but I'm going to draw a triangle. And they're giving us sine. So they're giving us opposite and hypotenuse. So from our theta, the opposite side is 3, and the hypotenuse is 4. Okay? Well, if we're going to go and find all 3 of the double angle formulas, or we're going to use all of them, we're definitely going to want to find this missing side here. Okay? So right now we have opposite, hypotenuse. We're going to want to find that adjacent side. So we have to use just a quick little Pythagorean theorem to get there. So 3 squared plus, I'll just call it x squared equals 4 squared. going to give us 7, so x is the square root of 7. So our adjacent side is the square root of 7. Okay, now we can basically just dive right into these formulas. So sine 2 theta is equal to, this is right from what we wrote down back here, it's equal to 2 sine theta times cosine theta. Okay, so now we just go back to our triangle and we find those two things. So sine of theta is opposite over hypotenuse. So opposite is 3, hypotenuse is 4. Substitute it in. Do the same thing for cosine. Cosine is adjacent over hypotenuse, so square root of 7 over 4. And you're going to get lots of fraction work in this lesson. So that's the setup. We just need to simplify it. So multiply straight across the top. 2 times 3 is 6 times the square root of 7. On the bottom, 4 times 4 is 16. And then we can work on simplifying 6/16. We can divide each of those by 2. So our final answer is going to be 3 root 7 over 8. I just divided the 6 by 2 and the 16 by 2. And that's going to be our final answer for that. Okay? Then we'll move on to our cosine of 2 theta, which is cosine squared theta minus sine squared theta, which in our case, we just need to find cosine and square it, and our sine and square it. So cosine, we've already done it on our last problem. That was square root of 7 over 4. And sine, we've also already done that. That was 3/4. So not too difficult there. Square each of those. So when you're squaring a fraction, you square the top, square the bottom. So square root of 7 squared is 7. 4 squared is 16. Minus 3 squared is 9. And 4 squared is 16. And then we just do that. 7 minus 9 is negative 2. Keep your common denominator. Don't subtract those. That'd be bad. Keep 16. And then that reduces to negative 1/8. Divide them both in half, and we're done. Okay? And then tangent 2 theta. This one's formula is has a little bit more to it. This one is 2 tangent theta over 1 minus tangent squared theta. Okay? So 2 times tangent, we've done that one. Have we done that one? We haven't done that one yet. Tangent, opposite over adjacent. So opposite was, we go back to our triangle, opposite was 3, adjacent is square root of 7. Over 1 minus, now that tangent squared. So 3 over root 7 squared. Okay? Then we just have a little bit more work here to get this one looking nice. So on top, we have 2 times 3 is 6 over root 7. On the bottom, we have 1 minus 3 squared is 9, and root 7 squared is just 7. And then we should actually do that subtraction. So instead of this 1, I would change that into what it is in sevenths. So I'm going to rewrite the whole thing just to stay clear here. So top stays the same. On the bottom, instead of 1, let's change it to 7/7 so that we can subtract 9/7. So that's going to give us 6 over root 7 over 7/7 minus 9/7 is negative 2/7. Okay, we're getting there, but that is still pretty ugly. So instead of dividing, let's multiply by the reciprocal. So I'm going to multiply by negative 7 over 2, which is going to give us 6 times negative 7 is negative 42. And then on the bottom, 2 root 7. And then one more thing we can do, 42 and 2 are both divisible by 2. So we should do that. Get myself a little more room here. Divide each of negative 42 and 2 by 2. So we get negative 21 over root 7. And that's your final answer. If you want to rationalize the denominator, we haven't been really fussy on that this year, and that's because on the AP exam they don't mind if you leave it that way. But if you wanted to, when you wanted to multiply by root 7 over root 7, you would end up with negative 21 root 7 over 7. So this is also a good answer, maybe an even better answer than leaving the square root of 7 on the bottom, but not necessary. You can leave it either way. All right, one more example here using the double angle formulas, and this one is a cosecant. So cosecant, remember, is the reciprocal of sine. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. And we like our hypotenuse to be positive, so let's put this negative with the opposite. Keep our opposite as negative 2. Okay, so cosecant of theta is 5 over negative 2, and our angle, our theta, in this case, is between 3 pi over 2 and 2 pi. And we're going to be finding all three of our double angles again. Okay, so first thing I would do, draw a picture. 3 pi over 2 is right here, and 2 pi is right here. So basically, we're drawing our terminal side in the fourth quadrant. So to do that, we don't need to be super perfect, but kind of make yourself a right triangle there. And we want the hypotenuse to be 5, and we want the opposite to be negative 2. So we didn't do a very good job drawing to scale there, but that's okay. Okay. Now our next step is to figure out what this missing side is. So do a little Pythagorean theorem to get there. Negative 2 squared plus x squared equals 5 squared. So we're going to end up with x equals the square root of 21. And then always just kind of double check, make sure that if it's positive, it's supposed to be positive. And in this case it is. We're traveling in the positive x direction. So we're good with leaving it positive. If our angle had been over here, then it would need to be negative because we've traveled in the x direction in negative distance. But we're good with the positive version here. Okay, so going through all of these once again. So sine 2 theta, I always like to start by writing down the actual double angle formula. So this one is 2 sine theta cosine theta, which in our case is 2 times sine is opposite over hypotenuse, so negative 2/5. And then cosine is adjacent over hypotenuse, so root 21 over 5. And then we just multiply that out. 2 times negative 2 is negative 4 root 21 over 5 times 5, which is 25. And there's nothing we can do there. 4 and 25 are not divisible by the same thing. No common factors there, so we're good. Cosine 2 theta. That's where we do cosine squared minus sine squared. And this one, for whatever reason, I always set those up first. And then I'll fill in the fractions there. So cosine is root 21 over 5. And sine is negative 2/5. So square each of those, each part. We're going to end up with 21 over 25 minus 4 over 25, which is, actually going to go down here so we don't run into our tangent stuff. 21 minus 4 is going to give us 17. Can't do any more there, so we're done. And then last one, tangent. Tangent is 2 tangent theta over 1 minus tangent squared theta. In our case, tangent is opposite over adjacent, or OA in SOHCAHTOA, so negative 2 over root 21. over 1 minus tangent squared, so negative 2 over root 21 squared. And then these guys, you just gotta work with them until they get as simple as you think you can get them. So 2 times negative 2 is negative 4 over root 21, that's in our numerator. And then we have 1 minus, be careful here, negative 2 squared is actually positive 4. Negative times a negative is a positive, so 4 over 21. And then remember what we did in the last example, we changed that 1 so that it was 21 over 21. I guess in our last one it was, what was it? It was out 7, so we had 7/7. So I'm gonna do, maybe I'll kind of just do scratch work here. So 21 over 21 minus 4 over 21 is 17 over 21. So we end up with negative 4 over root 21 over 17 over 21. This whole denominator just comes down to 17 over 21. Okay? Then fraction over a fraction is ugly, so instead of dividing by a fraction, multiply by the reciprocal. So multiply by 21 over 17. And we're going to end up with negative 4 times 21 is negative 84 over 17 root 21. And it's fine if you leave your answer like that. You could rationalize the denominator, but I'm not going to on this one. I'm just going to leave it like that and move on here. Okay, so that kind of covers your double angle formulas. Next thing on tab is half angle formulas. So half angle formulas are listed here, and you probably just want to pause and write those down. I'm not going to talk too much about them other than this symbol. So this is an alpha symbol. It's just commonly used. If you were to Google like half angle formulas, it might show it to you that way, so I just wanted to show it to you that way. You could easily keep using the theta sign. You could use just a capital A. If you really wanted to, you could use the alpha sign. I think as I go through the notes here, I think I just used the theta sign over and over. So don't be confused by that. It's just a different variable, one that you might see. Okay. So as you're writing these down, you'll notice that there are these plus minus symbols here. And we are going to decide as we go through these problems whether we're using the positive version or the negative version. So we just kind of need to remember the all students take calculus thing. And really all we care about are the first and second quadrants here. So in the first quadrant, all are positive. So if your angle, as we're going through these problems, if your original angle ends up in the first quadrant, it's going to be positive. Okay? If you end up in the second quadrant, if you end up over here, that's the S for students. So your sine is going to be positive, but cosine and tangent would be negative up in that quadrant. So, and we'll go through that in the problems, but that's how you're going to decide whether you use the plus or the minus. Okay? So why? What is the point of this? Why do we do half angle formulas? And I didn't really talk about that much with the double angle formulas or at all. But the half angle formulas, I think it makes sense why this might be useful. So say you didn't have a calculator and you wanted to figure out what cosine of 15 is. Say for whatever reason, you needed to do that by hand without using a calculator. Well, you couldn't do it because 15 isn't one of the ones that we kind of have memorized, or one of the ones that's on the unit circle, because it's not a 30, 60, 90 triangle, and it's not a 45, 45, 90 triangle. So 15 degrees would be like this. If we want to do cosine, we would need adjacent and hypotenuse, and we wouldn't know what those are. But if we rewrote it as cosine of 30 degrees over 2, well, we could figure out what cosine of 30 degrees is. So if I change this into a 30-degree angle, I could say that this side is 1, and this side is 2, and this side is the square root of 3. So I could do cosine 30, And if I can do cosine 30, and if I know about these half angle formulas, I could then go and find, I could go and find what the cosine of 15 is. So I'm actually going to kind of go through this one and do this one really quick. This might not be one that you want to write down. We have a couple more examples that you could write down, but I would maybe just kind of sit and watch this one as I go through it. So this is how you're going to do it when you're using the half angle formulas. You actually double your angle, put it on top, and divide by 2. So hopefully you can realize that 30 over 2 is the same as 15. And then we would use that cosine one. So we would say cosine of 30 over 2 equals, okay, now we decide if it's positive or negative. Well, our 15 degrees is definitely in quadrant 1, so it's going to be positive. Everything is positive in quadrant 1. Okay, so we just use a positive instead of a negative there. Okay, then we would do 1 plus cosine of 30. Okay, so I'm following our formulas that we just wrote down. So cosine of 30 would be square root of 3 over 2 over 2. Okay, and for this one, I'm not even going to simplify further. We will be doing that, but I just want to show you just why this works, why this is important. So what I did is I went on Desmos and I typed in cosine of 15. So I do have a calculator now. I typed it in. It tells me that the answer is 0.9659, blah, 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 blah. Okay? Then I use that formula, the 1 plus cosine of 30 divided by 2. I typed that in, and you'll see that we got the exact same answer. Okay? Now, could I figure out what that decimal version is without using a calculator anyway? Probably not. But I would have an appropriate answer without using a calculator by doing that. Okay, so at this point we will go into some examples. So this is where you're probably going to want to start writing again if you didn't write that last one down, and we'll go through some half angle formulas. Okay, so cosine of pi over 8. So first thing we're going to want to do here is turn these guys into degrees. Just because I think we're a lot more comfortable with degrees, so I'm going to convert them all to degrees. So to do that, just a little scratch work off to the side. Pi over 8, if we want to convert to degrees, we can just multiply by a conversion factor. The one I always use is there are 180 degrees in pi radians. So if I want to get rid of pi, I'm going to put pi on the bottom. I want to keep degrees, so I'm going to put them on the top. Now I can cancel the pi's. I end up with 180 degrees over 8, which if you did the math there, you would end up with 22.5 degrees. Okay, so what we are actually doing is we are finding cosine of 22.5 degrees, which is not on our unit circle. 22.5 degrees is not on there. We couldn't find the cosine of it by hand without using a calculator. But we can double it. So 22.5 times 2 is 45 over 2. Okay, and 45 is something that we can deal with. Okay, so now I would draw a little picture of this. I kind of like to sketch where the original is, just with like a dotted line. So 22 degrees is about there. There's 0 degrees, 22 degrees. Here's 90 degrees. Okay, and we're in quadrant 1. Okay, that's important to decide if we're going to use a plus or a minus. So we're in quadrant 1. Everything is positive in quadrant 1. So we're just going to make a little note. We're using cosine, yes. Cosine is positive in Q1. So as we write down our formula, we're going to use a positive sign and then a big old square root sign. Okay? And then the cosine one is 1 plus cosine of 45. So we are using this number. We're using ones that we are familiar with. I'm just going to write that down for now. Over 2. Okay, so 1 plus, now we need to add to our picture here a 45 degree angle. So we're kind of going to split that, call that 45 degrees, And like I said, I'm going to use 1, 1, and root 2 for the 45-degree angle. Okay, so cosine is adjacent over hypotenuse, so 1 over root 2. All over 2. Okay, then we need to simplify this, and I'm kind of particular about the order in which I do this. The first thing I want to do is get rid of this guy. So instead of actually like rationalizing the denominator, I'm actually gonna multiply, switch colors. I'm gonna multiply this whole top by the square root of 2 and this whole bottom by the square root of 2, okay? So I would suggest you guys do the same thing as you're simplifying these. What that will do for us, if we kind of distribute this, 1 times the square root of 2 is the square root of 2 plus, what's going to happen there? You have a root 2 on top and a root 2 on bottom, so they're basically going to cancel, and you're just going to end up with 1. So root 2 plus 1. That's a lot better looking than what we had. And then on the bottom, 2 times the square root of 2 is just 2 root 2. Okay? And that's an acceptable way to leave that one. There isn't anything else that you can really simplify there. What I would be careful of, though, is making sure that it looks like your square root covers the whole thing, which mine wasn't doing a very good job of. So that one is actually fine like that. Again, you could rationalize the denominator and keep going further there, but I'm okay with you leaving it just like that. All right, moving on to a tangent example. So tangent of 15 degrees. Hopefully as I go through these, you're starting to get a little more comfortable with them. If we're already in degrees, great news. We can keep it in degrees. What we're going to do is double that angle. So 15 times 2 is 30 degrees, and then put it over 2. So we haven't really changed anything. We've just changed the way that it looks. Okay, at that point, we will sketch a picture to decide if we should be positive or negative. 15 degrees, again, that's a small angle. You're going to be in quadrant 1. Everything is positive in quadrant 1, so tan is positive. I think we'll get to a negative 1 eventually here. So we're going to use a positive version. Tangent is 1 minus cosine of 30 over, what is it, 1 plus cosine. Like so. Okay? So now we need to draw our 30-degree picture. This gets a little messy. So opposite is going to be 1, 2, square root of 3. Cosine is adjacent over hypotenuse, so root 3 over root 3 over 2 over 1 plus root 3 over 2. Okay? And then very similarly to what we did on the last one, basically we want to get rid of those fractions. So easiest way to do that is to multiply everything by 2. So we're going to multiply by 2, multiply by 2. That's going to leave us with 2 minus, those are going to cancel, root 3 over, distribute that, 2 plus, 2's are going to cancel, root 3. Okay? Now, that is an acceptable way to leave an answer, but I do want to talk about one more thing quickly. So if you are happy with that, I'm happy with that. But for some of us who want to go a little bit further, dig into that a little deeper, make that look even a little bit nicer, what we can do on ones like this, these are called conjugates. So you have 2 minus root 3 and 2 plus root 3. They're conjugates of each other. So this is just kind of like, we'll call it extra. So what you can do on one like this to simplify it further is on top you have 2 minus root 3. I'm going to put them in parentheses. On bottom you have 2 plus root 3. What you can do to simplify further is you can multiply the denominator by its conjugate. So the conjugate of 2 plus root 3 is 2 minus root 3. And we're going to do the same on the top. So that's legal. We're multiplying the top and bottom by the same thing. We can do that. Now what happens if you double distribute FOIL, however you learned that, if we multiplied all of these guys out, I'm going to do that. 2 times 2 is 4, plus, actually I guess it would be a minus if I'm doing first, outer, inner, last. So now I'm doing this guy, so minus 2 root 3. Then inside, plus 2 root 3. And then last would be square root of 3 times negative square root of 3, which would be negative 3. Okay, if we did that, you would have negative 2 root 3 plus 2 root 3 is 0. Those go away. 4 minus 3 is just 1. So what we have at this point is we have this big old square root sign still. On top, we have 2 minus root 3, 2 minus root 3 over 1. Now, if you think about the top in a different way, you have the same thing times itself. 2 minus root 3 times 2 minus root 3. That could be rewritten as 2 minus root 3 squared. Okay, now you have this big old sign out here, this thing, this square root sign. The square root of something squared is just that something. So those guys would cancel each other off. The square root of 1 is just 1. So that whole mess actually just simplifies to 2 minus the square root of 3, which is a much cleaner answer. So again, this is one where if we were in school, we may spend a little bit more time on working with conjugates, but for our purposes right now, if you left your answer like it was written up here, fine. If you want to go through the extra work to do the conjugate and simplify it further, awesome. That would be great. Okay, 2 more examples we have to do here, I believe. So example 5, use half-angle formulas to find cosine of 105 degrees. Okay, so first thing is figure out where 105 degrees is. So we have 0, 90, 180. So 105 is like 15 past 90. So we're in quadrant 2. And remember, in quadrant 2, only sine is positive. All students take calculus. So cosine is negative in quadrant 2. Okay, so that's going to be helpful when we set up our big old square root thing. We're going to have a negative out front. Okay, so as we go through here, we want to double that. So cosine 105 times 2 would be 210 over 2. Now we want to find that 210 degree angle. So 180 plus 30 more would give us 210. So we have a 30 degree reference angle. Okay? And then for those, remember, I'm going to use 1, 2, square root of 3. Be careful with positives and negatives here. Okay? We are going to the left square root of 3, so negative square root of 3. We're also going down 1. So negative 1 there. Okay? Now, when we set up our big square root, we need a negative because of this. And then the cosine half angle formula is, just gotta find that really quick, 1 plus cosine of, in our case, 210 over 2. So 1 plus, use parentheses here, cosine of 210, would be adjacent over hypotenuse, so negative root 3 over 2 all over 2. And then we just have to clean that up a little bit before we're done. So I would multiply by 2, and I'm multiplying everything by 2. So at that point we would have 2. These guys are going to cancel, so then we can decide what our sign is going to be here. We have a negative and a positive. The negative is going to win, so minus root 3 over 4. That's fine. You can leave your answer like that, or you can realize that the square root of 4, the denominator, is actually just 2. So you could write this answer as just your square root on the top. So 2 minus root 3 on the top over the square root of 4 is 2. Either one of those would be fine. Totally acceptable answers there. All right. And then last problem here. This one's just a little trickier than some of the other ones, so I just wanted to make sure that I gave you a look at something a little bit trickier. So here we go. So it's telling us that tangent theta is 2, and theta is between 0 and pi over 2. Find sine of pi over 2. So it's theta over 2. So it's just kind of a different way to tell you that you're using your half angle formula. Okay. So what I would do first is draw a picture, and we are between 0 and pi over 2. And you want tangent to be 2. I would write that as a fraction. It's not written as a fraction currently. Write it as a fraction. Remind yourself that tangent is opposite over adjacent. So when we draw this picture, we want the opposite side to be 2, the adjacent side to be 1. And since we're finding sine, we are definitely going to want to find the hypotenuse. So 1 squared plus 2 squared equals, we'll call it x squared. So we're going to end up with the square root of 5. Okay? And then we're using sine. So sine of theta over 2. We don't know what theta is in this case. We haven't really had one like that. It's going to be equal to square root, positive because we're in first quadrant, 1 minus cosine of theta over 2. So in our case, 1 minus cosine would be adjacent over hypotenuse. So 1 over the square root of 5 all over 2. And then how I would deal with that is I would multiply everything by this icky denominator, square root of 5. So distribute that out, and you're going to end up with square root of 5, those cancel, minus 1 over 2 root 5. Okay? So lots of fractions, lots of math, lots of algebra. Definitely brings in a bunch of the trig stuff that we've been working with all year. But once you get the hang of it, it does, in my opinion, actually end up going pretty smoothly. So there's an assignment. Go for it. Good luck.